In this video, we are going to learn about how to create a schematic symbol and PCB footprint for dual operational amplifier IC. For this tutorial, I'm considering an example for LM358 IC, which consists of two operational amplifiers in single package. Stay tuned till the end to understand how to create two different parts in a single library by using a schematic symbol wizard. This is very useful and very important as a PCB designer. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. This video is divided into four important parts. First one is understanding the datasheet and understanding the pin configuration of two different ICs in single package. Second step is to creating a schematic symbol using EasyEDA. The most important part is to creating two different symbols in a single library. That's going to be a very interesting part. Third step is to creating a PCB footprint of a PDIP IC which is associated with the LM358 in this particular example. Last but not the least, to understand how to combine a footprint that we have designed and also with the schematic symbol that we created, and make it a single library so that whenever you use it in application, it becomes a one particular component library. I am super excited to share you one important trick or a specific skill which required for a PCB designer in component library design. So let's get started. Alright, now we are in front of a datasheet for LM358 IC. Here we have different varieties available for this particular dual operational amplifier IC manufactured by Texas Instruments. But right now I am focusing on the LM358 and LM358A series, or maybe LM258 and LM258A series. To be specific, I am interested in LM358 because it consists of PDIP package, which is plastic dual inline package. Or maybe we can consider LM158, which is also having a CDIP package. But for this tutorial, I'm focusing on the PDIP package, which are basically same. PDIP and CDIP both are same, which is having a dual inline package with a 8-pin IC in a through-hole technology. If you are interested in SMD technology, then of course you can explore that in this particular package design activity, but schematic symbol design remains same. The most important part in this entire datasheet for us at this point of time is all about understanding the parameters of this IC, which is essential for understanding the electrical property. And most important one is pin configuration. If I scroll a little bit down, you can see here the pin configuration and functions of this ICs is given in this particular page, wherein we can see that PDIP and CDIP is having the simple and straightforward 8-pin IC package. And in that, pin numbers are associated for each and every functionalities of that particular IC, and it is given whether they are input pins and output pins, which is so-called electrical properties. These are the essential information which we have to understand before jumping into creating a component library. Last but not the least, one last important information is understanding the land pattern of CDIP or maybe a PDIP package, which we have done already in our previous tutorial. That's why I'm not going to dive deep into that particular concept. So let's get started with the schematic symbol straight away. Now I am on EasyEDA. I'll go and start designing the schematic symbol for dual operational amplifier IC. First thing is I'll go to the file and create a new symbol. The first important thing you need to understand here is making this symbol aesthetically good. We have two options here. One option is creating a IC based visual design which consists of 8 pins, pin number statically indicated as indicated in our data sheet. You can see here the similar to this one we can create a schematic symbol. That is one option which is straightforward and easy one. But it doesn't give a very good user interface or visual appearance to the design engineer. And for designing the operational amplifier circuits, we need proper understanding and representation of the circuit. That's why we are going with a little bit different way, which is all about creating a triangle and making it look like a real symbol, which is represented in IEEE standard. So for that, we'll start designing. Alright, now after creating this much of schematic symbol which consists of only one operational amplifier with the power pins, notice I have increased the size of the pins by using this parameter which is called length parameter for the pins, and also I have created a stroke width of the body of the operational amplifier as a 2-stroke rather than using a single stroke. That gives a little bit appearing, the better way of representation of operational amplifier. And also I have changed the color of VCC to red so that it indicates power, and also ground to black, that indicates the ground connection. Now what we are going to do is we are going to save this particular schematic symbol. I know it is still a single operational amplifier, but I'll give you the next procedure. First thing, I'll save it. I hope you have noticed that I have copied the information about the supplier, supplier part number, and manufacturer and manufacturing part number from the Moser Electronics India, because this is the genuine website where you can get the source of information and the data sheet authentically from the manufacturer. That's why I have copied it from the Moser. But if you are interested to go with a DigiKey, Arrows, and any other particular supplier or a vendor who are having a very genuine data sheet and genuine information, you can go ahead with that. Choice is yours, but at this point of time, I'm going with a Moser. And once I'm filling this information, I'll click on Save. Now, the magic part is something here. When I complete this particular component, I'll go to the library and I will go and search for that particular part, and I'll make sure that I'm in my particular library, which is all about workspace. And in that workspace, I can see my design, a schematic symbol visible to me. It is still a single operational amplifier IC without having any footprint attached to it, which is fine. What I'm going to do is I'm right click on it and add a subpart, or you can go with the add subparts. When we click on that, it will ask you the number of subparts you want to create. In this case, I'm going to create 2 subparts because we know it is going to be dual IC or a dual operational amplifier in single package. So I'll click on OK, and it will create 2 different subparts for that particular IC. Now if I search it once again, and you can see that 2 subparts are created. First one is having a VCC and ground. Second one is also having the VCC and ground. What we need to do is we need to select that second part and click on Edit. Here I'll remove the VCC and ground part. Make sure that you are clicking on the second part which is created and then going inside and changing these details. Removing the VCC and ground is one part. Second part is changing in 1 and in 2, because we have to upgrade it to the second operational amplifier, right? So into inverting and into non-inverting. So here I'll change it to into inverting. And what about the number? So it is going to be into inverting as a 6th one. So I'll change it to 6. And electrical property will be input only, because similar one which we did for the previous one, into non-inverting, and it is going to be 5th pin. So thereafter output is going to be out 2, which is just to change like this, and then output is mapped to the 7th pin. So I'll change it to the 7th pin. This is all about creating a second part of the single library component. Now once we are done with that, I'll save it. Once I'm done with saving, I'll just close both the windows, go back to the library and click on refresh button here. And then you can see that the first part is having a VCC and ground. Second part is having only input and output pins, no VCC and ground. And if you click on the library, a complete component library, it shows the VCC and ground included one. I hope you understood the entire process. This is absolutely a special skill every schematic design engineer or hardware design engineer should know about in any EDA tool. But right now I'm using EasyEDA, that's why I'm referring to EasyEDA only. Now next step is to create a footprint for this particular IC and associate them. Alright, now we are done with creating a PCB footprint for a PDIP IC with a 8-pin structure. I hope you remember we have discussed about this particular design or PDIP 8 IC design in our previous tutorial, which is all about 555 timer IC. If you have not watched that, please go ahead and watch it to understand the Cartesian geometry behind it. If you still have a question, feel free to ask me in the comment section below. Now what we are going to do is we are going to assign this PDIP IC to our dual operational amplifier which we have designed just now. First of all, we need to save this particular PDIP IC and then go ahead and associate it with the schematic symbol we have created. To save it, I will use a PDIP IC technology or PDIP IC name only, PDIP_08, and the tag is going to be DIP ICs, which is a category of plastic dual inline, and in description I'll change it as a plastic dual inline package with 8 pins. Now we are done with saving this particular PCB footprint for LM358 IC that we are designing right now. Now let's talk about how to assign this particular PCB footprint to the schematic symbol that we have designed. For that, I'll go to the library and search for LM358, and in my workshop, I'll go to the library which I have recently created. Make sure that the library is already having a part 1 and part 2 as we discussed previously. Now I'll click on the edit by placing the selection on the major IC, which is the category of that particular parts. So I'll just click on that and I'll come to this particular IC. You can notice the name as a full name, not having any .1 or .2, which is not a sub part of the main part. Now I'll go and click on the footprint option and I'll search for PDIP, which I have just now created. So I'll just change it to PDIP_08 if I'm not wrong. Yes, correct. So here I have a PCB footprint that I have recently designed and I'll double click on that. Or you can click on the update footprint also, which is your choice. After that, I'll cancel it and I'll come back and save the entire schematic symbol. Now we are going back to verify here on the library and I'll refresh the page here a little bit. And you can see that this particular component library is associated with a single package, though it has 2 different parts. You can see the first part is also having the same footprint or same package, and also the second part is also having the same package. Both are sub part of the main library, which is all about LM358 AP. How to verify this one? Very simple. I'll go to one dummy schematic. I'll create a new project of a schematic. I'll not save it. I'll just create it, and there I'll go to the library and I'll click on the entire main part, not on the sub part. You can still click on the sub part and place them, but I'll choose to click on the main part and I'll place it. Here you can notice that the first one is U1.1, the designator you can see there. And the second one is U1.2, and third one and fourth one. I hope you are very clearly noticing the difference between all of these. First one is having a VCC and ground. Second one is a part of the main part, which is LM358 AP. That's why it doesn't have VCC and ground. At the same time, if we go for a U2 of 1 or U2.1, you can see VCC and ground, and U2.2 is not having VCC and ground. This is how technically and a representatively correct way of creating a dual operational amplifier schematic library in a single package. This is the right way of representing it. It makes more sense and more aesthetically looking good for the design engineers or a schematic engineer to design a circuit using these kind of symbols. I hope you understood the very important concept of creating 2 packages or 2 different parts in a single package IC. Alright, I believe that you have enjoyed and understood the entire tutorial of creating a dual operational amplifier design in a single package. I hope you understood the entire concept here. If you are not confirmed with the process, please feel free to ask a question in the comment section below. Thank you so much for watching this tutorial. See you again in the next one. Until then, tune yourself, to make a difference.